Good morning or good afternoon or good evening, whenever you're listening to this. Thank you for learning today. Today we're going to learn how to add and subtract polynomials, how to multiply polynomials, and in the next video, we're going to use Pascal's triangle to expand binomials. So if I want to find the sum or difference, right, add or subtract two polynomials, I'm going to stack like terms. You'll notice that the x squared and the 7x squared are alike, minus 6x and minus x are alike, plus 5 and minus 9 are alike. So when I stack them, it just makes it easier sometimes to see what needs to be added with what. So 7x squared plus 2x squared minus 6x and minus x, those get added and subtracted, and we get our final answer, 9x squared minus 7x minus 4. In the next problem, we need to distribute this minus symbol to each term in the second group. A group is inside of these parentheses. And then again, we're going to stack like terms. So we have 3t cubed minus 5t cubed, 8t squared plus t squared. Over in this second set, there is no t term, so I don't have anything under the t term, right? And then I have negative 4 minus 17. And when we combine like terms, we have our final answer of negative 2t cubed plus 9t squared minus t minus 21. And that is how you can add and subtract polynomials. In order to multiply polynomials, sometimes we have special product patterns, right? If you have a sum and difference, like if you have adding x plus 3 and then subtracting exactly the same things, x minus 3, that just, you square the first, right, and square the last. You might have a square of a binomial, but remember that this square means that you're taking the a plus b times itself, or the y plus 4 times itself exactly. You end up with a middle term, okay? And then you might cube a binomial. A plus b cubed means you're taking a plus b times another a plus b times a third a plus b. And you end up having 4 terms here, okay? So we have these examples that I'm going to go over together, right? Our first one, 4x squared plus x minus 5 times 2x plus 1. Give us some space to work this one out. I'm going to use a box to multiply these. I'm going to use the box method. So 4x squared plus x minus 5, I'm going to make those the columns of my box. And then 2x plus 1, I'm going to make those the rows of my box. And when I multiply, I'm really finding the area of each rectangle within my box, right? So x squared, or 2x times 4x squared, and 2x times x, and so on and so forth. So when I multiply this 2x times each of my columns, I get 8x cubed plus 2x squared minus 10x. And then the plus 1 times each column. And you'll notice here what happens is that not all of the time, but quite frequently, you have the diagonals ending up as your like terms. So we're actually going to combine 4x squared plus 2x squared. And we're going to combine x minus 10x. And when we combine our like terms, we get our final answer, 8x cubed plus 6x squared minus 9x minus 5. Okay. A few more examples. Take a break. Okay. Our next problem, we have 3 binomials being multiplied together. And when you do that, just work on 2 groups of them at a time. I like to start with the last 2 and multiply these together. And then I'm going to work in whatever's in front of it. And if there's more things still in front, and if there's more things still in front, I will just keep adding them in, right? Or multiplying them in, I guess, as it were. So to multiply these two binomials together turns into, I have the first thing that stays the same and it stays there. It doesn't disappear. That is one of the most common mistakes I see people make, is that they will just stop writing the first thing and then they forget that it's there and then they don't know why their answer is incorrect. Write it down so that you don't lose it. Okay, m minus 1 times m plus 3 is going to turn into m squared plus 2m minus 3. And then the next group, I'm going to show you another method instead of using a box. I like to call this method the superfoil method. I'm going to take m and multiply, multiply, multiply. And that gives us m cubed plus 2m squared minus 3m. And I'm going to take this negative 2, watch your signs in there, and multiply, multiply, multiply. And I'm going to stack my like terms and then get my final solution. Now, plus 2m squared and minus 2m squared, those cancel out, right? So really, I'm just looking at m cubed minus 3m and minus 4m to get minus 7m, and then plus 6. Our next example, we have the quantity 5a plus 2 being squared. Okay, so that means that I need to multiply 5a plus 2 times 5a plus 2. If you would like to FOIL this out or use a box to multiply it the long way, that's totally fine. Here's a shortcut. Square the first term, 25a squared. Multiply and double, so 5a and 2, you multiply those to get 10a, you double that, and you get 20a. And then square the last term, which is just 4. So your answer is just 25a squared plus 20a plus 4. Neat trick, isn't that? All right, this next problem, we have the quantity xy minus 3 being cubed, okay? So I'm going to go over here and use the cube of a binomial pattern, right? I notice that I have a subtract here. So I'm going to use this pattern right here where it's a cubed minus 3a squared b plus 3a squared ab squared minus b cubed, right? So I'm just going to draw it out. Instead of a's and b's, I'm going to write some blanks, okay? I have blank cubed minus 3 blank squared blank plus 3 blank blank squared minus blank cubed. In my first sets of blanks, I'm going to put the xy, 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 xy. And then in these second sets of blanks, where the b's were up here, I'm going to put the 3, 3, 3, and 3. And then I just need to simplify this. So xy cubed means xy times xy times xy, right? So the x is being cubed and also the y is being cubed because that's in parentheses. And you go through and do all of that to the rest of it. We get our final solution, x cubed y cubed minus 9x squared y squared plus 27xy minus 27. And that is your final answer for this problem. Thank you for watching, and thank your brain for learning.